You've probably seen it, right? A massive construction site with these huge chunks of earth carved away, and you just kind of wonder, how does all that dirt just stay up, you know? We see solid ground and we think it's stable, we think it's strong. But sometimes, in a flash, all that stability just disappears. So today, we're going to dive into the science of slope failure and figure out why that solid ground isn't always as solid as it looks.
I mean, it's a pretty terrifying thought, isn't it? One minute, you've got a perfectly stable hill. The next, it's a catastrophic landslide. Now, this isn't just random chance. This isn't some freak accident. There is some powerful science at work here, a literal battle of forces happening right under our feet. So, what's the trigger? What's the secret ingredient that turns solid earth into a flowing, deadly river of mud? To really get why a slope collapses, we first have to understand the constant, invisible battle it's fighting, day in and day out. And that whole battle, it starts with the most basic, fundamental force there is, gravity. Okay, so picture this. Every single slope is in a constant tug of war. On one side of the rope, you have the soil's own internal strength. That's all the friction and the particles clinging together trying to hold on. And on the other side, just the relentless, nonstop downward pull of gravity. As long as the soil's strength is winning that fight, everything's fine. The slope stays put. And that brings us to the main event, slope failure. This is the exact moment that tug-of-war is lost. It's the tipping point where gravity's pull finally overwhelms the soil's ability to hang on. And let me be clear, this isn't some slow, gradual process. It is a sudden, catastrophic event. The rope in that tug-of-war just snaps. So if slopes in nature have this kind of balance, what is it that throws everything off? Well, a lot of the time, the answer is us. The whole story takes a really dramatic turn when we start digging and reshaping the land for our own purposes. Think about it. Nature can take thousands of years to gently form stable slopes. We can come in with heavy machinery and create these super steep, artificial ones in a single afternoon. When we dig into the ground for roads or buildings, we completely disrupt that natural balance we were just talking about. And when we do that, we essentially start a ticking clock. Now, that new artificial slope, it might be stable for a little while. It might look perfectly fine. But then the villain of our story shows up, a powerful catalyst that can absolutely cripple the soil's defenses against gravity. And that villain is water. And when it comes to water, there are really two main troublemakers. You've got heavy, sustained rainfall. That's the obvious one. But what's just as dangerous is poor drainage. That's when water gets trapped, it has nowhere to go, so it's forced to just soak deep down to the ground. A problem, by the way, that's often created by the construction work itself. So how exactly does a little H2O do so much damage? Well, it's a nasty four-step chain reaction. First, the rain just soaks the soil, right? Then, as more and more water fills up all the tiny gaps between the soil particles, it starts building up pressure. It's literally pushing the particles apart from the inside. This makes the soil's internal strength, its ability to grip itself, absolutely plummet. It's kind of like a dry sponge, you know? It has some structure, but a soaking wet sponge, it's just a weak, mushy mess that falls apart. That's our slope. And once that strength is gone, gravity always wins. And this brings us to the most critical phase. The water has done its dirty work. The soil is incredibly weak, and the entire slope is just balanced on a knife's edge. This is that terrifying moment right before the disaster. This quote right here gets to the absolute heart of the danger. A lot of the time, there are warning signs. You might see small cracks or little bulges in the ground. But here's the thing. Slope failure is not a slow slide. It is a sudden, catastrophic collapse. Ignoring those early signs is a huge gamble against a force, gravity, that does not negotiate. The balance is gone. The forces holding that slope together have been fatally weakened. And that ticking clock we talked about, the one we started when the first excavator bit into the dirt, yeah, it just hit zero. But hey, this isn't just a story about destruction and doom and gloom. It's also a story about human ingenuity. Because if we understand the forces that cause a collapse, well, then we can design amazing solutions to prevent it. We can actually fight back against gravity. And here they are, the heroes of our story. Engineers have this whole toolkit to keep slopes stable. You've got retaining walls, which basically act like a giant, strong brace providing outside support. Then there are soil nails and anchors. Think of them like giant pins that stitch the ground together from the inside, making it stronger. And most critically, improved drainage, which is all about getting that water away from the slope and tackling the problem at its source. The crucial takeaway here is that these disasters are almost always preventable. This is a predictable result of physics, not some random act of God. It really shows us that the biggest risk isn't the sudden rainstorm. It's the plan that we make or fail to make long before the first shovel ever hits the dirt. Real safety comes from proactive engineering control.
And why does all this matter so much? Well, because the stakes just could not be higher. We're talking about protecting the lives of workers on construction sites. We're talking about safeguarding multi-million, sometimes billion-dollar buildings, bridges, and investments from being completely destroyed. And at the end of the day, we're talking about ensuring the safety of all of us, the public, who will live and work and travel around these structures for decades.
So let's end with this thought. Every single time we cut into a hillside or dig a massive foundation, we are starting a conversation with the fundamental forces of nature. And the earth, it always responds. It talks back with tension, with pressure, with those little warning signs. So the real question is, are we actually listening? Because understanding that dialogue, the one between our ambitions and the planet's physics, is the absolute key to building a safer world.